So it says in this question, okay, last one, the function f of x is equal to x cos x, okay, which is this function over here, okay, and it said it had, if you look at in the diagram above, it says p is an x-intercept, and the estimate of, and one estimate of that is it's equal to x coordinates of p is negative 1,5. And the question says use Newton and Raphson's method to determine p correct to 4 decimal digits. Well, that's a pretty straightforward one, this one here. So you're going to say, right, x to the r plus 1, just copy this down from the formula sheet, is equal to xr minus f of xr over f dash of xr. They've given you your first guess. So we're going to use x0 is equal to negative 1,5. Okay, so on our calculators, okay, well, we first, sorry, I've lost a bit of focus. The next thing we have to do, sorry, before we can go on with this, is we need to find f dashed of xr, which is probably the most work in this sum. So we have f of x is equal to x cos x. Remember, you've been doing a lot of integration, don't mix up integration with differentiation. So this differentiation, so when you use the product rule, so f dash x, and the product rule says we take the derivative of the first thing, which is 1, the second thing stays the same, so it'll be 1 times cos x, then a plus sign in between, then this thing stays as the first term there stays the same, and I take the derivative of cos, and the derivative of cos is negative sine x. So the derivative equation for this function is cos x minus x sine x. Right? So now I go back here and I place those values into that formula for Newton's method. So I get x to the r plus 1 is equal to xr minus f of xr is xr cos xr over f dashed of xr, which is cos x minus x sine x. Okay? Right, so now what we have to write down is our different. So you're going to say, right, the first guess is equal to negative 1,5. What I'll do with my calculator, negative 1,5 equals, so you store it all clear. And then you're going to, on your calculator, you don't have to write this down obviously, you're going to have xr plus 1 is equal to answer minus answer times cos answer, okay, answer cos answer, yeah, so wherever we see xr, I'm changing that into answer button on your calculator, over cos answer minus answer sine answer, making sure you're in radian mode. Okay, so we've replaced wherever there is an xr, I've replaced every xr, that should have been xr and that should have been xr. I've replaced every xr with answer. So it's answer minus answer cos answer minus answer sine answer. Okay. You don't have to write that answer bit down. Okay. And they want the answer correct to 4 decimal digits. So write down your iterations. So x1, our first x1 was x0 is equal to negative 1,5. Okay. Then x1 is equal to, okay, x0 is equal to negative 1,5. x1 was equal to negative 1,57, negative 1,574438. x2 is equal to negative 1,5708. Okay, right, so up to here we've got corrected 2 decimal digits, so I don't have to write down more than that then. Okay, well let's just see, 08, so a few more, 04. Okay, x3, okay, is equal to negative 1,5706. 579,632. So now we've got correct up to 3 decimal digits, those repeat. And then x4 is equal to negative 1,570,7963. Okay, so we've got now correct to a whole lot of decimal digits. We've got correct to, what's that, 7 decimal digits, but the question said only give your answer correct to 4 decimal digits. So I go to the first digit, 1, 2, 3, 4, 5. That would be 5 digits. Okay, so I round back to get 4, and that 9 pushes that 7 up. Okay, so your final answer is P, which was the x coordinate of the intersection, is equal to negative 1,570,8. Okay, which is that point of intersection over there. And that is Newton's method done. If you want some extra practice, okay, there's some worked examples from page 293 to 296 of Mind-Born Maths. There's also that exercise in your textbook, and the memo has been put up on Teams. And that is it for Newton's method. Danko. Righty. Okay.